Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 3 of the clocks series. In case you've not watched parts 1 and 2, then there will be a card for you right here. If you've already watched those 2 parts, then I want to congratulate you for making it all the way because this is going to be the last and final video in this series. By the end, you will have completed an analog clock which will work alongside the digital clock. Alright, let's begin. First, we need to add a small change to the digital back. While the clone has been created properly, there will be a bug if you move it in the preview screen. To fix this, we just set the position of the sprite to x0, y130. Now it's time to move on to the analog clock's back. The sprite will work identically to the digital back, except that it functions for the analog clock. When the sprite receives an init, we of course have to delete all of the clones. Then we set its position as x0, y-50. The sprite itself should stay hidden, so a hide is important. The hands of the analog clock have to be shown in front of the sprite, so we also send the sprite right to the back layer. It's time now to initialize the clone variable. We first set the variable to yes, then create the clone and then set it back to no. As I mentioned several times earlier, this variable will differentiate the clone and the sprite. When the tick message is received, the clone has to show itself while the sprite should remain hidden. To do this, we simply check if the clone variable is set to yes for the particular object, and if it is, then show. Okay, so that's everything we have to do for the analog clock's back. If you test out the code right now, the analog clock's back should appear right below the digital clock. Let's move on to the hands of the analog clock. When the sprite receives a init, we delete all of the clones and then hide the sprite. We now have to go to the exact same location as the analog clock's back, so that will be x0, y-50. We can first create our clone variable to distinguish between the clones, and we can then set it to yes and then initialize another variable for the sprite only called type. The type variable will allow us to differentiate between the clones themselves. Remember that there are 3 hands for the clock. The type variable for the hour hand will be set to hour, the type variable for the minute hand will be set to minute, while the type variable for the second hand will be set to second. Now that we're creating the clones, we first set type to hour and then create a clone. Then we set type to minute and create the next clone. Finally, we set type to second and create the last clone. Once all of this is done, as usual, we set clone to no. Before we proceed, I think it is necessary to explain the way the clones will move. If we look at the costumes tab, the costumes are not really centered but are instead moved to the right. This should be obvious when you think about it. The hands of the clock are fixed at the end where they touch the center of the clock itself, and all the remaining part of it rotates around that point. The second thing I want to mention is that the costumes themselves are shown when they are pointed in 90 degrees. What this means is that no matter how the costumes are drawn here, they will look this way when the sprite is pointed in a right angle. So for example, if we drew the arrow straight up in the costumes tab, then this is the way the arrow will look when it is pointed at 90 degrees. My point is that the way the arrow is drawn in the costumes tab determines the directions that it will be drawn in. This becomes very important once we start to make the clock hands move. Getting back to the clock hands, we next have to program the script when the tick message is received. We are only using the clones, so we can start with an if clone is yes, and if this is the case, show. Beyond this, we have to change the directions for each of the hands differently, so we need to go through each type one by one. If the type is hour, then we point in direction total seconds divided by 120. Now you are probably wondering how I got this number, and I will explain this eventually. At this moment, just follow me along. Just pointing in the correct direction is not enough, and we also need to change the costume to the hour hand. Now we can duplicate the entire if-else statement and just change the type to minute. Here we will point in directions total second divided by 10. After this, we switch costume to the minute hand. In the case of the second hand, we point in direction total seconds multiplied by 6 and then change the costume to the second hand. Okay, so that was a lot, and it's time to go through how we arrive at the directions. The second hand should be the easiest to think about. Once 60 seconds are completed, the second hand moves across a complete circle. This means that 60 seconds corresponds to 360 degrees. What this simplifies to is that for every increase in 1 second, we turn 6 degrees of the second hand. Let's now take the case of the minute hand. For every 60 minutes, the minute hand moves around a complete circle. This means that every 60 minutes corresponds to 360 degrees. This in turn means that the minute hand will turn 360 degrees for every 3600 seconds. What this simplifies to is for every increase in 1 second, the minute hand moves 1 divided by 10 degrees. So if the change in seconds is total seconds, the minute hand must move total seconds divided by 10 degrees. Lastly, let's do the calculations for the hour hand. For every 12 hours, the hour hand moves by 360 degrees. If we take the hours in seconds, it means that the hour hand turns 360 degrees for 43,200 seconds. What this simplifies to is that for every increase in 1 second, the hour hand moves 1 divided by 120 degrees. So if the change in seconds is total seconds, the hour hand must move a total of total seconds divided by 120 degrees. Alright, that's going to be everything that needs to be done for this program. If you test out the program right now, you should see the digital clock and the analog clock working perfectly side by side. If you've enjoyed making this simulation, then make sure you click on the playlist on your screen right here. Thanks for watching, and I'll see you in the next video.